Question we are solving now belongs to test series 10. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the question, there is a RLC circuit given as shown in the figure. The RLC circuit contains a 10 volts voltage source, 1 ohm resistor, and a switch S1 which is closed at t equal to 0. It contains a half farad capacitor as well. The voltage across the half farad capacitor is Vc of t. There is another 1 ohm resistor and 1 Henry inductor in the circuit, and there is a 2 ampere current source which is connected across the 1 ohm resistor through a switch S2, and the switch S2 is opened at t equal to 0. So from the given data, there are 4 options given. The options are Vc of 0 plus is equal to 2 volts, IL of 0 plus is equal to 2 ampere per second, dVc by dt, di by dt at t equal to 0 plus is 2 ampere per second, dVc by dt at t equal to 0 plus is 8 volts per second. If IL of t is the current flowing through the inductor, we need to find the correct option out of this. From the given data, we see that the switch S1 is closed at t equal to 0 and switch S2 is opened at t equal to 0. So let us draw the equivalent circuit at t equal to 0 minus. So as the switch S1 is closed at t equal to 0, the 10 volts voltage source is disconnected from the remaining part of the circuit at t equal to 0 minus. So from this we can draw the equivalent circuit as shown. The equivalent circuit contains the inductor, capacitor and 1 ohm resistor. It contains a 2 ampere current source as well. From this we can see that as the switch is as the circuit is in the state shown from t equal to minus infinity to 0, we can say that the inductor acts as short, and the capacitor acts as open. From this we can say that IL of 0 minus is equal to 0 ampere. Due to the reason that capacitor is open, the inductor will not carry any current, and Vc of 0 minus can be seen to be 2 volts. This is due to the reason that the 2 ampere current will flow through the 1 ohm resistor. Hence Vc of 0 minus can be written to be minus 2 volts. This is due to the reason that the drop across the 1 ohm resistor is 2 volts. So now let us analyze the circuit at t equal to 0 plus. From the given data, we see that at t equal to 0 plus, the 10 volts voltage source is connected to the circuit through the 1 ohm resistor, and the voltage across the half farad capacitor can be written as 2 volts with the polarities as marked, and there is a 1 ohm resistor and the 1 Henry inductor, and the inductor is carrying a current of 0 ampere. This is due to the reason that as the inductor does not allow abrupt change in current, IL of 0 plus is equal to IL of 0 minus is equal to 0 ampere, and also as the capacitor does not allow abrupt change in voltage, Vc of 0 plus is equal to Vc of 0 minus is equal to minus 2 volts. From this we can say that as the 1 ohm resistor and 1 Henry inductor do not carry any current, the polarity at the point marked is minus 2 volts. Hence the current through the 1 ohm resistor, that is I of 0 plus, can be written to be I of 0 plus is equal to 12 divided by 1, that is equal to 12 ampere. So from this we can say that the drop across the 1 Henry inductor, that is VL of 0 plus is equal to minus 2 volts. That implies di by as VL of 0 plus is L multiplied by DIL by dt, we can say that DIL by dt at t equal to 0 plus is equal to minus 2 divided by L. As the inductor is having an inductance of 1 Henry, we can say that this is equal to minus 2 ampere per second. And also we can see that the current I of 0 plus will be flowing through the capacitor. Hence we can say that IC of 0 plus is equal to 12 ampere. Hence as IC of 0 plus is C multiplied by dVc by dt at t equal to 0 plus, we can say that dVc by dt at t equal to 0 plus is equal to 12 divided by C. As the capacitance is half farad, this is equal to 24 volts per second. From this we can say that IL of 0 plus is obtained to be 0 ampere. Hence the option B is not correct. Vc of 0 plus is obtained to be minus 2 volts. Hence the option A is not correct. VL of DIL by dt is obtained to be minus 2 ampere per second. Sorry, this is minus 2. Option C is correct. dVc by dt at t equal to 0 plus is obtained to be 24 volts per second. Hence the option D is not correct. Hence the correct option is C.